into the world of numbers and equation. It's another day, another chance to dive into the wonders of mathematics. Last time, we unraveled the mysteries of graphs of polynomial functions. And guess what? Today, I am your master, Riza Palabrica, and I'm here to serve up a hearty, healthy brainstorming knowledge in module 2 solving problems involving polynomial functions. So, get ready because we're gearing up for an exhilarating adventure that's not just going to amaze you, but will also leave you with a mind truly enlightened. As always, the module that we have referred in our discussion are from the Department of Education Cordillera Administrative Region. Are you ready, masters? Let's jump in.
The aforesaid equation are first degree, second degree, and third degree polynomial function known as linear, quadratic, and cubic function, respectively. Take note that in general, a polynomial function, usually denoted by p, x, or fx, is a function defined by. Alright, dear learners, if you're excited as I am, let's dive headfirst into our very first example. We will explore how the perimeter area and volume of geometric shapes can be expressed using these powerful functions. Let's dive in. Let's begin with squares. To find the perimeter, that's the total length around it. We just add up all four sides or simply multiply one side's length by 4. So, the formula for the perimeter P is PS equals 4S, where S is the side length. Consider a square with sides each measuring 4 units, plugging in 4 into our formula. P4 equals P4 equals 16 units. Therefore, the perimeter is 16 units. Now, let's shift our attention to the area enclosed by the square. We calculate it using AS equals S squared, where S is a side length. For a square with sides of 4 units each, A4 equals 4 squared equals 16 units.
Furthermore, to compute for the volume or capacity of the box, we multiply the area of the base B with the height x of the box. Thus, the volume of the box is V equals Bx, which when further solved will give us V equals 4x cubed minus 16x squared plus 16x. This again tells us that V depends on x. Thus, V is a function of x, or V of x. Thus, V is a function of x, or V of x equals Bx, or that V of x equals 4x cubed minus 16x squared plus 16x. These are the following solutions. For more deeper understanding, let's explore more knowledge. Stay tuned for more practical application in our next exploration in polynomial functions. Until then, keep those mathematical gears turning. Example number 1. A cube has a capacity of 125 cm cubed. What is the length of its edge? We begin with the formula for the volume of a cube, which is V cubed equals S cubed. In this case, we know that the volume is 125 cm cubed and we want to find the length of the edge, denoted as S. So, we substitute the given volume, 125 cm cubed, for V cubed in our formula. It looks like this. Next, we take the cube root of both sides to isolate S on the left side. It becomes the cube root of 125 centimeters cubed, and on the right side, we are left with just s. Simplifying further, the cube root of 125 centimeters cubed is 5 centimeters. So, our equation now look like this. Oh, therefore, the length of the edge of the cube is 5 centimeters. Find the polynomial function which represent the volume of a rectangular prism and with its zeros 3, -3, 1. To find the function representing the volume of the prism, we use the formula VR, prism, equals LWH. The zeros shall be transformed as a factors, and these factors will be substituted as the length, width, and height of the prism. Follow these steps below. Use the appropriate formula. Multiply binomials and simplify. Therefore, the polynomial function that represents the volume of the rectangular prism is v of x equals x cubed minus x squared minus 9x plus 9 cubic units.
Alright everyone, buckle up! We have reached our final example, so let's keep our knowledge up a notch. Here we go! Now, before we wrap up, remember to hit the like button, subscribe to our channel, and ring that notification bell. We have got more exciting math adventures waiting for you in our next video. This has been your math sir, Riza Palabrica. Until then, keep that mathematical enthusiasm burning bright. See you in our next video and have